All right, folks, here's another series circuit. It's almost exactly as the one we just looked at, except we have slightly different information, and what we're looking for is going to be a little bit different based on that information. So we still have this idea of, Ohm's law. So, everyone knows Ohm's law, V equals I times R, easy enough. And we also have this idea of taking our resistances and replacing them by what's called an equivalent resistance so that we can have a simple circuit to solve. And so with a series circuit, all we need to do is take our resistors that are connected in series, add them together. It doesn't matter how many resistors we have that are connected in series. For a series circuit, bam, we just add them together. And so looking at this circuit here, if I were to replace this by the equivalent circuit, we've got our voltage source. We're going to replace this by a single equivalent resistor. Now we don't know what voltage or voltage source is, but we know that our equivalent resistance, so I'm going to call that the total resistance, is just the sum of the series resistors, which is 5 from this guy, 15 from this guy. 5 plus 15 is 20. So we got a resistance of 20 ohms. Now we do know the current. And so the current is often expressed in line of my circuit because it's the electrons moving through the circuit. So I know that my current here is going to be 5 amps. And so this is actually enough information to apply Ohm's law. And so if I just write out what Ohm's law is, in this case my voltage source is going to be my current, 5, times my total resistance, which in this case is just 20. 5 times 20, of course, is 100. And I've got 100 volts going through the circuit, which I believe that's actually in this problem called VT for the total voltage. All right, so I know that this voltage source is 100 volts. If this were an actual circuit, I would suggest not touching this. 100 volts at 5 amps can give you a pretty good jolt. But again, now this is enough information to figure out the rest of the pieces of the circuit, because we already have talked about for series circuit, if my current's being pumped out by this voltage source, the electrons that make up that current, they have to go through R2, and they have nowhere else to go but through R1 and R2. It's got to be the same electrons, the same current, which has to be the same 5 volts. And so the rest of this problem is just a simple application of Ohm's law. And so if we were to solve this, step by step for these different resistors, V1 is equal to my current, which is going to be the same for everything, times the resistance in R1, and that of course is 5 amps times 5 ohms, which is going to be 25 volts. Now, we already know what the voltage across R1 and the voltage across R2 should add up to. They've got to add up to the voltage of that power source. So just looking at this, if I wanted to take a shortcut, I know my power source is 100 volts. So if we write this out in an equation, the voltage of the power source is equal to the voltage across, or the sum of the voltages across each resistor. And so the voltage of the power source is 100 volts. V1 is 25 volts. That's enough information to figure out what V2 is. We know V2 has got to be 75 volts. We can also do this with Ohm's law, just like we did for R1. So the voltage across resistor 2 is going to be the current through the circuit times the resistance across circuit 2. Well, I know the current's 5, same for the other circuit, or other resistor, times R2, which is 15. 5 times 10 is 50, 5 times 5 is 25, 50 plus 25 adds up to the 75 volts that we expect. And so again, all of these series circuit problems are just applications of Ohm's law over and over and over again until we get everything figured out in the circuit. So my advice, if you can't directly figure out something in the circuit, move your focus to a different element of the circuit and see if you can figure out something about that. If we, looking at Ohm's law, if we know two of these variables in Ohm's law, we can figure out the third, and that might help us figure out something else about a different element in the circuit. So good luck. Let me know if you guys need more help.